Hi everybody. Just wanted to discuss a little bit about JSON, or the JSON and the JSON schemas, and I'm going to make an assumption that you know a little bit about XML already. One of the things we noticed in terms of XML when it was initially introduced, it was very popular. A lot of people were using it for the interchange of data. Then along comes JSON, and what has happened is it's become widely adopted. And now it seems as though we need to know both XML and JSON. And so then the question, and this is sort of a debate that you'll have, which do I use? When do I use it? Why do I use it? Why are these two things in competition with one another? And I would point out that there are some specifications. There's a lot of discussion about it. There's pros and cons. These are different tools. They have different roles, and you can do different things with them. We'll do a little bit of a comparison between XML and JSON, and we'll talk a little bit about the JSON and JSON schemas, as well as the XML and the XML schemas, and how they are different and how they are similar. So I'm going to put this in slideshow mode. I'm not going to do too many lab exercises, although I do strongly encourage you to do them. What I want to do is sort of give you the quick overview. We already know XML a little bit. It's a way of structuring data. It's very tag heavy. The tags allow for attributes. The tags typically take up a lot of space, and this causes a little bit of overhead in data transmission and overhead in parsing. We have JSON, also a mechanism for structuring data, and we notice that JSON is a data format. And in some sense, one could make a compelling argument that a data structure is nothing more than a stupid programming language, but it is a nice way to interchange data between various platforms. So here's your basic XML document, and one of the things you can notice is that you can have duplicate tags. So here we have two authors, both of which are labeled with the tag author, and now all of a sudden it becomes clear this is not the same thing as JSON, and here's why. In JSON, you cannot have duplicate tags, and that means you have to have what they call a JSON array. So what we have here in XML is, and this is well formatted, right? We have a begin tag, book, an end tag, /book. Now we have title, end title, authors, end authors, and now we have several author elements. And as a result, this is where we would find a difference between XML and JSON. Here's JSON now. We have a single author's, we'll call it tag, and then we've got, or property if you like, and then we have an array, a JSON array of strings. And so that in and of itself, it doesn't seem like a remarkable difference. Moreover, the book property, title property, doesn't have a distinct match with an end title. So things are in the form of string colon and then the property associated with the name. So that's a sort of a difference. Makes things a little bit less wordy. Here we see the wordiness. It's a lot to type in comparison to that. There's a lot less to type, less to transmit, less maybe simpler to parse. Let's take a look at the side-by-side comparison. Here we see the authors all listed versus authors one tag at a time. So that's a big sort of difference. Another difference is that things are a little less wordy. Okay, that's fine. What else? Well, a few other things that go on. When you create lists in the sense of a JSON element, you're basically creating what's called a JSON array. The JSON array is a homogeneous array. We would expect every element in the array to be of the same type. And if you need, to put floating point numbers in there, you may need some sort of parsing facility. And that could lead you to problems down the road where things aren't being parsed properly. So now we've got meta languages, right? XML is a language. You can use that to create other languages. JSON is also a language, and you can use that to create other languages. In both slides prior, we saw how to use XML to create a book language consisting of books, titles, authors, and so forth. And in the prior slide, we saw how to use JSON to create a book language consisting of books, title, slide, author, and so forth. So the two things look roughly equivalent at this point, with the exception of the lack of duplicate tags. Moreover, we have two different structures for the XML data structure. We have a tree. People know what trees are. They know how to handle trees. Moreover, JSON objects give us trees with a difference. And the difference here is we have duplicate leaves on the XML with two different properties associated with them. We're here with authors. The only leaf is an array of elements that constitute the variety of authors that you might have. But other than that, tree's a tree. That's nice. It's a directed acyclic graph. No cycles in between the leaves. Nicely formatted, nicely easy to traverse. You can do depth first, breadth first, whatever you like. So we understand how to deal with trees. There are lots of algorithms available. Now let's take a look at schemas. XML schemas look rather complex. They have properties and attributes, two things which JSONs don't have. We don't have an attribute element inside of a inside of the angle bracket equivalent. So here we have an XML schema element. We've got attributes associated with that element, the name and the attribute associated with the name. The JSON equivalent schema has a rather different look to it, and one could make a compelling argument that it may be simpler. There's no recursion available to us. We cannot make new data structures. So these are limitations of JSON which make it simpler. On the other hand, one could make a compelling argument that it provides a limitation which makes it less rich. And so there are two different ways you can view this. The limitations define the language as much by what we leave out as what we include. And someone has made a conscious decision in the design of JSON to leave out recursion and to leave out the ability to create new data types. Two elements which you can have in XML. So if you really need those things, then maybe XML is the way to go. And if you don't need those things, then maybe JSON's okay. So here we have a title with a string type, and this here is what we would call type map, and the string which maps to that type. I'm not going to spend too much time on this. When we take a look at the XML schema correspondence to the author array, what we see is an element named authors. It's a complex type, right? We want simple types. We got a sequence with an author, and you could have the max number of occurrences for authors, and that can be specified. We have this sequence basically creating what we'll call a list of duplicate author names, and we call this the complex type. Here we have a JSON array that's coming in. We'll have at least one element and no more than 5, and then the type of items that comes in is string. And so that, in and of itself makes for the mapping between the array and the list of elements relatively isomorphic. Here we have another mechanism where we are specifying a date, and the XML schema type apparently comes in with something like a number and a year. And here we have something that involves a number and then a year with 4 digits, and it's supposed to correspond to some sort of regular expression pattern which is input into the JSON. Here we've got an interesting type called the enum. Enums allow you to specify what the publishers can be. So here we have a publisher map, and it's a string type, and it can be either Springer, MIT Press, or Harvard Press. And so now we've got a way to restrict which publishers are permitted. Here in the XML schema, we have the same sort of enumeration, so there is a direct mapping, but it looks really rather different, doesn't it? Now we have an XML element called publisher The minimum number of occurrences is 0, which means we don't have to have it. It's an option. It's a simple type instead of the complex type which we saw before. We could have a list of authors, and we've got to have one Springer, MIT Press, or Harvard Press publisher, or none. So I've got an XML schema written in XML. I got a JSON schema written in JSON. Both have schemas. They look rather different in terms of their structure. And so with an XML schema and an XML instance, I can go through a validator and make sure that we can parse things properly. Moreover, I can create editors which will help me to compose the XML schema. Similarly with JSON, I can have a schema and a JSON instance. That object can be validated. Moreover, I can have an editor that helps me to edit the JSON. So now I've got a whole bunch of validators and implementations available online. I got tools, I got a framework, and I can go in and paste in schemas and paste in JSON, and I can click on validate and do it without even running a program. I just input my JSON and it'll tell me the results of my validation. There's a command line ability to do the validator, but of course what will happen if you build your own parser in Java is you'll be doing the validation as you go. Then if there's an error in the JSON, in the data input, it will show up right away. Naturally enough, when you're doing validation in a Java program, you're going to get runtime errors, and the question of how you're going to recover from them remains open. That'll be a matter of policy as you proceed to do your implementation. But the same thing could happen with XML. If you have an XML parsing error on input, then you're going to have a problem, and the question of how you resolve the problem remains open. So now we've got schemas, 4 schemas, I guess you could call them meta schemas if you like, and now we can validate the schemas, which is presumably something you would do if you got into an advanced JSON state. Moreover, there's a bunch of people working on this. You can go to the Google Groups. Google has its own version of JSON, which they call JSON, which I can demonstrate for you in class. And you can discuss the schemas in their own groups. So there's a lot of discussion about this. It's still an emerging technology. If we look at what JSON is used for, here we can see a JSON visualization of tweets. One could make a compelling argument that you need these things, right? Because you want to see where the Twitter hot zones are, where are the people tweeting. Why you need that, I don't know. Perhaps you can come up with a way to use geotagging to try and figure out where the demographics are for people who are your clients. There's a bunch of people who will get together and discuss how they're going to move data from one place to another. It used to be called the Object Management Group, and they would worry about things like Common Object Broker Administration or CORBA. Now there's an OASIS group, and they're working on this so-called Open Data Protocol. If you wanted to move something like binary data, such as an image from one place to another, I don't think you'd want to use XML or JSON. I think it's really only good for text data. But you know what? These guys might come along and say, no, we've got a new UU-encoded base64 mechanism for moving blobs of binary data. Once that happens, the question of what you do with a 5 megabyte image remains open. I still don't think you're going to want to encode it in JSON, but maybe they'll prove me wrong. As a JSON, that's the Google JSON library, which is what I've been using, is freely available and open source. And you add a jar file in, and then all of a sudden you can start serializing instances of objects out to a file, then you can read them back in. And you could do the similar thing with XML. Both will be human readable, sort of. Both will be something you can edit, that's for sure. And the question of how human readable it is remains open. The XSLT equivalent for JSON doesn't exist yet. XSLT allows you to transform XML to another format, like HTML. JSON does not have this. I don't know if there's a need for these sorts of things. The claim that there is no tool indicates there's no need for the tool. I don't find that claim to be well-founded. Just because nobody invented the tool yet doesn't mean nobody needs it. And if you did invent the tool, maybe you'd have a need for it, and presumably you could demonstrate that need. And then people would come in and say, oh yeah, I do need that tool. So for example, here, let me give you a good example. Suppose you have an address book format, and there are standards for address book markup language. Well, now you want to translate from address book markup language to JSON. Sounds like an XSLT need to me. Maybe you want to go directly to JSON with some sort of translator. Or maybe you want to go from JSON to XML. I think that's doable. Or maybe going from XML to JSON, not so easy. So a couple of ways you can involve XSLT translations. Maybe there's not a big need for it. I don't know. There's an XML to JSON converter. Don't know how good that is. And it says right at the top, it's not 100% accurate. I would think that you would have some issues and you'd have to go through and hand edit stuff. Still, an XML to JSON converter might be useful for you. Here's an example of what comes in from the transform. So that's looking pretty good. If you want to devise a way to convert from XML to JSON, there's a lot of commentary about how hard this can be, especially if people are using recursive mechanisms for doing the transform. And so what we're going to do is we'll show you a few different things about JSON format and how to create JSON schemas. And for the JSON data format, we've got these wonderful railroad track diagrams, which you may have seen before. But what this essentially says is a value can be written as an object, or as an array, or as a number, or a string, or true, or false, or null. And that's it. That's what you get. So that's your basic data structure, and you can't create new ones on your own. An object, and that's one of the basic values, consists of a string followed by a colon followed by a value. And it's surrounded by curly braces, and if there's more than one string colon value, it's separated by commas. And so here's an example where you have name mapping to a property. Here we have an age mapping to a property. That's a value, which is 30. And you can see numbers are permitted. Married mapping to true, which is true or false. So you can have numbers, strings, arrays, and objects. Here we have an object that may be empty. So now we've got an empty object. It's surrounded by curly braces. And now you should think about objects as containing keys and values. So the key is title. But then the question is, can you have, multiple keys like we saw in XML? And the answer is no. Keys have to be unique. This JSON object is going to generate a parse error. So since you need unique keys, you've got a problem. If you want to do multiple things, you'd better put in an array. That's the JSON difference. So here comes the array. And now for the array, you can just say something like key, colon, then in square brackets, value, comma, value, comma, value. And now you're all set. You can have as many values as you like in theory. Values can have null in them. Values can have nothing in them. You can have comma-separated values with carriage returns inserted, perhaps for readability. Now we have siblings containing a list of, here's a JSON object, property, name, value, John, property, age, value 25, and that's coming in as an object, and then that's followed by value true, and then followed by string hello world. So these are what you would call array elements, and each one of the elements can be either an object, or Boolean, or a number, or a string, or perhaps even another object. Digits, I think, are fairly self-explanatory, and it's pretty obvious. You can have integers with this railroad track diagram, or you can have floating point numbers, or you can have the so-called E notation, so you can have exponentials in there. you could have 1E6, and that would be like a million. So here is John Doe. That's property name, value John Doe. Property age, value 30. That's a basic JSON object. And so then there's a question about characters. The business about converting from JSON to XML and XML to JSON is not entirely straightforward because XML characters are a subset of JSON characters. And so what that means is you have to be able to figure out how you're going to encode your JSON characters into the XML character set. And the JSON characters could be Unicode characters, whereas the XML characters could be UTF-8 characters, which would mean they're 8-bit ASCII characters. So what will happen then is you've got to escape and use the hexadecimal quantity for the Unicode character. Typically you use something like a backslash for that. And now you have to be confronted with a variety of different characters and their hexadecimal values. And this is just the ASCII characters. And if you wanted to do this for Unicode characters, you'd need 65,536 or 16 bits worth of character for Unicode. And so that gives you a more or less international mechanism for encoding characters that may be in a variety of non-English fonts. Unicode is, I guess they call it multilingual. In fact, if we look at the katakana, there are, if we include some of the ancient characters, even more than 16 bits worth of characters. But in general, 16 bits is enough to get by in every commonly used ideographic we know about. So I can't have a multi-line string. This is a carriage return inserted inside of the string. Right? You can't have that. You can use \n. Then you can have just two symbols. That's not the same if you go into XML. With XML, the new line characters are essentially going to be encoded differently depending on the platform. And so this brings up the absolute circus, that is, how to insert a carriage return in text. For Unix, it's a line feed. For Windows, it's a carriage return line feed. For the Mac, it's just a carriage return. All I can think of is somebody saying, can't we all just get along? Because I look at this and I go, what the heck is the matter with these people? If they could just agree on one thing, it would simplify everybody's code so much. But in fact, we now have these problems where if you try to communicate to a robot and you need a carriage return line feed, then you have to specifically insert these things before the robot will respond. Whereas some robots might only want carriage return, others might just want line feed, and if you put in \n, you don't know what you're getting. So it could just be a line feed, or in some platforms it could be carriage return line feed. You just don't know. This so-called solidus is a division character. The reverse solidus is the \/ character, which is a ASCII decimal quantity 92. \/ is typically underneath the vertical bar on the keyboard, whereas / is typically underneath the question mark. And you have to escape or use the control character, either \/ or quote, in order to be able to insert your Unicode character sequence. True and false are literals. So is null, both literals, all literals. You don't wrap these in quotes. And if you want, you can use null to indicate no value. And so 42, that's the answer to the universe, right? That's a legitimate JSON instance. And the quote, that's a legitimate quoted string, legitimate instance. True is a legitimate literal, and you can put all of these things together. True, null, 12, and a string. All things you can put inside of an array. So that's what I've got for you now. I think that's enough for you to get a feeling for the difference between JSON and XML. Hope you like my presentation. Talk to you later. Thank you. Boy.